Hello ladies and gentlemen, welcome to the Mali tutorials. In this video, we're going to talk on how to work out probability using the permutations and combinations which we were doing in the last video. So here our first question is saying a committee of 4 people is to be selected from a group of 10 people. What is the probability that a specific person, Alice, is in the committee? So here, first what we're going to do, let us write the formula for probability first. So question 1, solution here. Probability that Alice is in the committee is equals to the favorable outcome over the total possible outcomes. So this is the formula for the probability. So we know that the total possible outcomes, these are the total ways of selecting 4 people of the committee from 10 people. So we have done it before that selecting 4 people from 10 people, we use what we call the combination. So the combination formula is n choose r, where n is the total number of people and r is the ways, is the number of ways of choosing people. So here our n is 10, choose r, our r is 4. And now on the favorable outcome, we are saying that a specific person, Alice, is in the committee. So when Alice is already in the committee, it means now on n, on the favorable outcomes, the total number of people which we are left with, which is n, is equals to 9, because Alice is already in the committee. And then on R, we need to choose 4 people, but Alice is already in the committee, meaning to say now we are left with 3 people which we need to be chosen, because Alice is already chosen. So we are going to write 3. So meaning to say it's going to be 9 choose 3. So this is how we find the probability of Alice being is in the committee. So it's going to be equal to the favorable outcome, which is 9 choose 3 over 10 choose 4, which is equal to so here I've said that the shortcut which we are going to use here, we just say 9 second function, then press 5, just choose 3, then we'll just put this in brackets, all over all over 10 second function, choose 4, this is equals to 2 over 5. So this is the probability that a specific person, Alice, is in the committee using the combinational formula. So let us look, move on to the second question which we are having here. Is from a standard deck of 52 cards, 5 cards are drawn at random. What is the probability that all 5 cards are of the same suit? So we have been agreed that these 52 cards are made of 4 suits. So these suits include the clubs, the shovels, diamonds, and hearts. And we know that in each suit we are having 13 cards, which is equal to the total number of 52 cards. So now the question is saying find the probability that the 5 cards which are being drawn are of the same suit, meaning to say they are either of the club suit, or of the shovel suit, or of the diamond suit, or the heart suit. Therefore, let us first write the formula for probability, which says that the probability that 5 cards are of the same suit is equals to the favorable outcome over the total possible outcome. So now on the total possible outcome, we are looking at the total ways of selecting 5 cards from 52 cards. So the total possible outcome, we are going to use the combination formula again, which says n choose r, and our n is the total number of cards which we are having, which is 52 cards, and then we need to choose 5 cards. So this is the answer for the total possible outcomes. And then for the favorable outcomes now, the favorable outcomes, for favorable outcomes, we are being told, we are not being told the exact suit which are being selected. The statement is just saying that the probability that all cards are of the same suit, meaning to say they're either of the clubs or the shovels, the diamonds, or the hearts. So meaning to say, what we are going to do here, we are going to say we are going to choose either 13 of clubs, those 5 cards, or we're going to choose from the shovels, those 5 cards, or they're going to be from of diamonds or from hearts. So this is the answer for the favorable outcomes. Of 5, that 5 cards are of the same suit is equals to the favorable outcomes. You're going to see the here is going to be 13 choose 5, or 13 choose 5, or 13 choose 5, or 13 choose 5, which is simply 4 times 13 choose 5 over the total outcome, which is 52 choose 5, which is equals to, so we are going to say 4 open 13 second function 5 all over 52 second function choose 5. This is equals to 0.002. So this is the probability that 5 cards are of the same suit. So let us look on the third question. Let us look on the third question. So the third question now is saying a class has 12 boys. The third question is saying a class has 12 boys and 8 girls. If a group of 5 students is selected at random, what is the probability that the group will consist of 3 boys and 2 girls? So let us first write the formula. The formula is for the probability that the group will consist of 3 boys and 2 girls, which is equals to the favorable outcome over the total possible outcome. So here for the total possible outcome, we are going to say we need to choose what is the total number of people which we need to choose. So we are going to say 12 boys plus 8 girls, which is going to 20. So our n is going to be equals to 20, and the r, we need to choose our main students from these 20. We need to choose 5 students if a group of 5 students is selected. So therefore we need to choose 5 students. So our r is going to be equals to 5, meaning to say here on the total possible outcome is going to be 20 choose 5. And then for the favorable outcome, we are given a condition that we are having 3 boys and 2 girls, meaning to say our n for the boys is going to be equals to 12, and then the r, we are choosing 3 boys. And for the girls, we are being given that we are having the total of 8 girls, and then we need to choose 2 girls. Therefore, what does this mean? Meaning to say we are going to say the probability of 3 boys and 2 girls is equals to, for the favorable outcome, we are going to say this n, meaning to say multiplication. So we are going to say 12 choose 3 multiply by 8 choose 2 or over 20 choose 5. So this one is going to be, so we are going to say 12 second function choose 3, multiply by 8, second function, choose 2, then close the bracket, all over 20, choose 5, which is equal to 0.397. So this is the probability that the group will consist of 3 boys and 2 girls. Then let us move on question number 4. So question number 4, you are free, you can try this one on your own. You can pause the video and then you try this one on your own. It says a jar contains 7 red marbles and 5 blue marbles. If you draw 3 marbles at random, what is the probability that exactly 2 of them are red? So here we're going to say the probability that exactly 2 of them are red is equal to the favorable outcome over the total possible outcome. So now what it means that we are going to firstly calculate the total possible outcome. So for the total possible outcome, we are going to firstly n the total number of marbles which we need to select from. So we are going to say 7 red marbles plus 5 blue marbles is equal to 12. And then how many do we need to choose? If you draw 3 marbles at random, so our R is equal to 3. And then for the favorable outcome, so we are being given that what is the probability that exactly 2 of them are red, meaning to say we are selecting 2 from the 7 because 2 are red, meaning to say we are selecting them from this 7 red. So we are going to say 7 choose 2 of red, and then the remaining one is, meaning to say is of blue, multiply by the of blue 5. We're going to choose from 5 blues, and then we need to take 1. Therefore, meaning to say the answer here that the probability of exactly 2 of them are red is equals to the favorable outcome, that's 7 multiply by 5 choose 1 all over 12 choose 3, and then you're going to get what? So you're going to say 7 second function choose 2 multiply by 5 second function choose 1, then you close our bracket all over 12 choose 3. So this is actually equal to 0.4773. So that's the probability for number 4. So now let us look on number 5. We are being given a statement which is saying from a shelf of 8 maths book and 6 science book, you will randomly select 4 books. What is the probability that you select 2 maths books and the 2 science books? So we need to find the probability that of selecting 2 maths and 2 science books, which is equals to the favorable outcome over the total possible outcome. So now for the total possible outcome, our n is going to be equals to, we are going to calculate the total number of books, which way we need to choose these 4 books. So we're going to say 8 plus 6, which is equal to 14. And then the R, we need to choose 4 books. And then for the favorable outcomes, we're going to say firstly, it's what is the probability that you select 2 maths books. So we're going to say n for maths, so which is 8. And then R, we need to select 2 maths. And the n for the science, our main total books of science, we are having 6. And then the R, we need to choose 2. Therefore, meaning to say the probability of selecting 2 maths and 2 science books is equals to the favorable outcome. We're going to say 8 choose 2 multiplied by 6 choose 2 all over 14 choose 4, which is equals to, so we're going to say 8 second function choose 2 multiply by 6 choose 2 all over 14 choose 4. This is equals to 0.4196. On the last question, this question number 6. So the question number 6 here, I'm having question number 6 here, so I'm going to work it out here. So the question number 6 is saying 2 cylinders in an 8-cylinder engine are defective and need to be replaced. If 2 cylinders are selected at random, calculate the probability that both defective cylinders are selected. So here we are being given that we're having the total cylinders, which is our n, is equals to 8, and the defective cylinder is equals to 2. Therefore, we need to calculate, let's go on A, the probability that of both defective cylinders being selected, which is equal to the favorable outcome over the total possible outcome. So for the possible for the total possible outcome, we have said that we need on the total possible outcome, we are going to look at the total number of cylinders which you are having. So the total number of cylinders you are having is 8, and then we need to choose how many cylinders. We need to choose 2 cylinders which are defective. So our R is equals to 2. That's the total possible outcome. For the favorable outcomes, how many you're going to say n, that's the total number of defective cylinders which you're having, is 2. And then the R, we need the number of cylinders which you need to choose. We need to choose again 2, because it's saying 2 cylinders are selected at random. Calculate the probability that both are defective cylinders. But the total number of defective cylinders you're having is 2. And here on A, we are also choosing those 2 cylinders. So meaning to say, we're going to say 2 again. Therefore, the probability that both defective cylinders are selected is equal to, when I say the favorable, we're going to say 2 choose 2 over 8 choose 2. This one is going to give us 1 over 28. And then let us go on B. B said no defective cylinder is selected. So if no defective cylinder is selected, meaning to say our n for the total possible outcome is going to be 8, and then the R here is safe. If 2 cylinders are selected at random, calculate the probability that no defective cylinder is selected, meaning to say our R is 2, because we are selecting 2 cylinders. But now let us first write the formula after writing this one, that no defective cylinder, the rule that there's no defective cylinder selected, is equal to the favorable outcome. Now the favorable outcome is that we need to choose the number of cylinders which are not defective, meaning to say we're going to say 8 minus 2, which is equal to 6. So meaning to say the total number of cylinders which are not defective is 6. So we're going to say 6 choose, and then we're choosing 2 cylinders over 8 choose 2, which is equals to, you're going to get 50 over 28. And then let us go on C. C is saying at least one defective cylinder is selected. So on this one, which is saying at least one defective cylinder is selected, when the question is saying at least one defective cylinder is selected, it means it can be either 1 or 2 or 3 as it going upward. So therefore now the opposite that of at least one defective cylinder is that no defective cylinder is selected. So if we are having the opposite, the opposing statement, which if we are able to find the opposite probability, we are going to say 1 minus the opposing no defective cylinder is selected, which is equals to 1 minus no defective cylinder is selected is 15 over 28, which is equal to 13 over 28. So guys, this is how we apply the permutations and combinations in calculating the probability question. So thanks for watching guys. Don't forget to subscribe, like and share.